Hello, and welcome to On Air, the podcast from Altitude Angel. I'm joined again by Richard Parker, our CEO and founder.
Steve.
I'm Philip Beans, our head of ATM.
Yeah, good afternoon.
And I'm Stephen Farmer, and I'm the head of communications. So, yeah, afternoon, gents. Been a busy week, busy 2 weeks. Skyway. Should we go straight in? Boom, massive news. Do you want to tell us a little bit about it?
Yes, Skyway, in short, is a drone superhighway technology we've been working on for quite a while. And through Innovate UK, we've announced recently some funding, which is allowing us to extend our 8-kilometre test corridor down in Reading up to 265 kilometres in the UK within the next 2 years. And that will take the corridor broadly from the south in Reading all the way up to Coventry, out to Cambridgeshire, Oxfordshire, through Milton Keynes and lots of other areas along the way.
So, I mean, this has been hailed in the press, we've had some brilliant press. I mean, it's been great about everywhere. So I won't just take all the credit for that, but I did have a lot to do with it. It has been hailed as a bit of a game changer. So, Binksy, how is this going to change the game?
I think the important thing to highlight here is this is not segregated airspace. This hasn't got a temporary danger area. It hasn't got a TMZ. No protection around it at all. So we call it a superhighway, or other people call it as a corridor, but that just means the drones will travel up and down those superhighways. It doesn't prevent any other airspace user from accessing the airspace, and that's a critical difference. Because at the moment, any BV loss operation taking place in the UK is done by special exemption from the Civil Aviation Authority, or there's a temporary danger area, or there's some other form of airspace restriction around. And of course, that just isn't scalable, is it?
Yeah, but we all know how our General Aviation fans appreciate TMZ, whatever, don't they?
Yeah, we do. Well, exactly that. We don't want to make life more difficult for the current airspace users. We can integrate drones without forcing other airspace users to do something else, do something different, or to buy really expensive equipment. Well, surely we should be looking at that solution rather than just saying, right, everybody in the air now has got to buy this really expensive kit and put it on board in order for this new airspace user to come in. So, yes, there will be give and take. Rules will have to change as the air. As the air gets more complex, more dynamic and stuff like this, the basic set of rules and the way people operate will have to change slightly to allow for these new airspace users. But come on, we're a new industry. Surely, we're a tech industry. This man comes from a technical background. We're using that technology now to try and get into the airspace safely and integrate rather than segregate.
On the tech, do you want to just give us a little bit of an explanation about how it does actually work?
Yeah, well, I think springboarding from what Phil was saying, one of the big goals of Arrow, which is the system which is delivering the superhighway functionality in Skyway, one of the biggest goals was ensuring that there was no change to the status quo from a traditional aviation user's perspective. So Phil's touched on the very light touch implementation that's going ahead, which means no TMZs, no danger areas are required in order for Skyway to function. That's key. And equally, we don't require any kind of transponder technology to be added to an aircraft that might not have it. That also extends to drones. So we don't require drones to have so-called hook-on devices, which are pretty much nonsense anyway, unless you only care about tracking the drone versus being able to talk back to that vehicle, which is what Skyway can do. So in a nutshell, the way Skyway works is it's able to deploy a series of low-cost but high-resolution sensors up and down a known location, and then it uses that sensor data in real time to create an ultra-high definition map of the low-altitude sky. And in other words, it allows the digital air traffic control services to see, quote-unquote, aircraft in the airspace. And then one of the clever things it does is it's able to match what it can see on those sensors with telemetry from cooperative drones, and then very basically is projecting where everything might be and is able to nudge cooperative drones out of the way of something that is either uncooperative or is perfectly entitled to be there, it's just not using Skyway. And that's a final point I think that's just so important to remember is there's no difference to what we're expecting general aviation, commercial aviation users to do. There's equally no difference to any drone user that just wants to fly in a Skyway area but doesn't want to benefit from Skyway. So you can be flying, your Mavic Air or whatever it is, and everything else in Skyway will just move around you. So I think it's that inclusivity is really, really key.
Now, one of the questions I think we were asked after the last podcast was the likes of paragliders and these sort of airspace users who tend to be lower than sort of general aviation, your Cessna pilots. So there's going to be no problem for those guys if they're flying within what would be one of the Skyway corridors.
Well, I think with that is, of course, they can't flight plan. They can't go from this point to this point to this point. They are generally using thermals, using other technology. They can have a little motor on the back or engine on the back to fly around as well. But the key is they won't have a fixed flight plan. And therefore, you can't necessarily use a flight plan to go, actually, I'll use some sort of strategic deconfliction against them. So you do need other sensors. And what you're saying is absolutely correct. You can set up the sensors and they will detect paragliders, hang gliders, and people like that. In fact, my brother, he's a paraglider in the Lake District, and when I was talking to him about it, he thought, wow, that's really, really interesting. It's purely because he says he has to deal with fast jet traffic. He said, can you pick up fast jet traffic? I said, well, yes, we can do that. He said, well, can I find out about fast jet traffic? He said, well, that's a different story altogether because you're a paraglider and how you're going to get that information. However, we can provide a situational awareness. How that situational awareness therefore gets used, how that information gets used, is another story, because it comes down to an airspace authority who might want to use it. I'd just like to add, though, another key element to this is we're talking about corridors, but there are no reasons why these things can't cover areas. You know, they don't have to be long, thin corridors, of course.
So to that point, actually, I think there was another article that was written, and there was a bit of a criticism that we were making a corridor and that we were mirroring the roads and we need to think wider than that. Obviously, yeah, we can. At the moment, we are just doing a one corridor, but we will. With more towers, we can cover more areas, and they become more zones. Or
well, to those people, I would argue that it's fine to advocate for a more freeform use of the airspace, but I remind people that we're in a situation today where this stuff just isn't possible at all, and what people are trying to get to is a more freeform use of the airspace, and there isn't a capable mechanism going from one state to the other, except for Skyway. Skyway is very familiar to aviation regulators. It's very familiar from a risk and safety management perspective because it mimics the way that early aviation got started with known routes and known corridors. To the people that compare Skyway to a motorway or a highway, I would simply say it's not like a 3-lane motorway or a 4-lane motorway. It's 8.5, 9 kilometres wide, and with a vertical extent which is artificially constrained at the moment at 400 feet. So if you think about the average width of a drone, or even a very large drone, something like 4 or 5 metre wingspan, we can cram an awful lot of traffic in these areas. And certainly with the Skyway corridor in its proposed route now, even though it is only, quote unquote, 265 kilometres long, 8.5-ish, 9 kilometres wide, it covers 15% of the UK population. So, this is a transformative technology. And as Phil said, these can become areas. We already have partners that are looking to extend off of this and create what we call spurs. And actually, there's no reason that an aerodrome or an airport facility can deploy 2 or 3 of these and cover the entire area. So, what we're witnessing here is just the beginning, but it is a credible beginning, and it's a proper stepping stone from the state that industry is all in today and where it wants to get in the future.
Because it can also rejuvenate general aviation airfields. They can look to other use cases now. Can they start introducing urban air mobility or sort of air taxis into their airport or into their airfield? Or can they start using as a cargo hub and stuff like this? And so, because they don't have to fork out for very expensive radars, they can use our technology. Well, are there some more use cases and start utilising the concrete we have on the ground, the airfields we have on the ground, for different tasks and different use cases? So that's another conversation that is taking place in the background. We've had a number of conversations with general aviation airfields, airports, and I think that's going to be really, really interesting how that actually expands and grows and stuff like this. So we are working, people say we don't want to close off the airspace. Well, we're certainly not doing that. We want to open up the airspace and actually use the assets that are available today in a far, far better and more efficient way. So that's quite exciting, to be honest.
I think on that point as well, it's critical to remember the airspace is basically closed to automated drone traffic today, period, right? Phil described a few different types of exemptions which exist that allow one company to get airborne at a specific time in a specific place. But Skyway enables any company to get airborne in a specific place. And that's a massive paradigm shift. It means now you could have multiple delivery services operating in a city like Reading or up in Coventry, whereas there is no equivalent for that today. So even if we'd like to get to this kind of free-form use of the airspace, it's simply not possible from today's regulatory perspective and landscape to imagine that that could happen in the short to mid-term. Skyway's secondary function is to collect evidence on how drones can be flown safely and how multiple companies can work together and how we can rely on sensors so that we can collect data which can be presented to the regulator. So I understand and accept the quote unquote the criticism, if you like, that it doesn't go far enough, but the reality is it doesn't go far enough because it's impossible to go that far today without taking this interim step. And this is still going to unlock so much value in the drone industry to be able to get out there and do everything from life-saving operations all the way through to commercial industrial use of drones. It is purely a transformative step, and it's going to be absolutely key for the country and for the industry.
So what's the timeline? When? This is the big question, is when we're going to start seeing drones fly.
Well, we'll start seeing drones fly once we complete the first towers, which will hopefully be the first 9 going in later this year and completing by sort of Christmas time frame. It's our goal to have the entire Skyway operational by summer next year. And then that gives us time effectively to start trying longer distance flights. But that is the Skyway program is a 2-year program. But alongside that, the Civil Aviation Authority have got to come along for that journey to get the certifications in place, such that at the end of the Skyway program, 2 years is ample time. And actually, it's also worth remembering we've had an innovation team now for 4 or 5 years, something like that. We've been engaged with the CA. By then, it will be 7 years. And I remind all the watchers of this podcast that it took NASA 7 years from idea to completion to put someone on the moon for the first time. So I always maintain this is easier. So, within that 2-year time frame, it would be entirely feasible to expect that there's sufficient evidence collected to prove that this technology is capable of certification, and it would be the first public superhighway that existed anywhere.
I think what's important to know, this isn't just for the UK.
Correct.
This is something that UK PLC can export. We can, as a country, can be leading the way.
But a lot of regions have asked. Coming from all the PR that you've done, Steve, and in fact, it's been amazing PR. Coming from all the PR that you've put out, it's been amazing. And there are a lot of other regions very, very interested in this technology. And in fact, there's been a number of states in the US who I spoke to at Farnborough Airshow last week who are going, well, can it be exported? Can we have a look at it? Can you do this? Can you do that? And it's like, well, these are conversations we want with you guys. But we've got to understand we'd have to work closely with the regulators in various regions. But we would certainly be up for it. There's no reason why we wouldn't be. And we can get this technology out there. And to enable the drone industry, whatever region of the world it is can only be a good thing.
And that's the key, right? We've designed the Arrow technology, which powers that Skyway functionality, to be scalable and effectively limitlessly scalable. And the way that we've designed the operating program behind it is that we can establish a partner in a country or a state, and then that partner can be enabled to go out and build the necessary infrastructure and to create those services and make it available. So it's a kind of a portable solution that works pretty much in any country, as Phil said. But the reality is, going back to your point, yes, this is a technology that UK PLC can export, but UK PLC has got to put its support behind it, and certainly Innovate UK have taken that first step. Really now it's a case of which state is going to be the first to certify it, because as Phil said, there are already lots of American states that have contacted us. We are working very, very closely with our friends in the Netherlands as being potentially the next European state to take the technology, but it's also ours to lose in the UK. If we don't hurry up and certify it, it will happen somewhere else first.
So I think it's been a brilliant announcement. We've got a lot of work to do, but it's going to be an exciting 2 years. Well, 2 years and beyond. I mean, Skyway is a project, 2 years. So, Phil, you mentioned Farnborough, so just a little touch on that. You've been to Farnborough probably countless times. It's my first time this year. A lot of UAM there.
There was a hell of a lot of UAM, which is great to see. A lot of money, but as we know, there's a huge amount of money that's gone into UAM. I think there's the first quarter of last year, something like $53 billion of SPAC money went in. So there's a huge amount of investment. It's just great to see. You start to see different airframes and stuff like that. But at the end of the day, that's still that big unanswered question. How do you get them into the airspace? How are you going to manage the UAM? Are we going to just go fall back on the good old traditional ATM? Or are we thinking about moving forward and actually...
There's a lot of acronyms in this.
Yeah.
We need a glossary. We'll flash up a glossary.
Yeah. But we know that that's not scalable.
Well, I think on that point, sorry, I was going to say, it's good to see that money going in, and I agree it's great for the industry, but let's remember that the vast majority of this air taxi money is basically electric helicopters at the moment. It's still piloted. There are one or two UAM companies out there that are thinking about automation and trying to get to that point. But the reality is everyone's just left with a shiny electric helicopter fleet at the end of it, unless there are technologies like Skyway in place so that they can start to fly more as a drone and less like an aircraft. Because I think that's, correct me if I'm wrong, but I think that's the current way that many of these are thinking about being integrated into existing operations today, is basically as a helicopter.
I'm assuming there have to be what we call instrument flight rules. So you're relying on instruments. Standard separation applies. That's 3 mile separation against all other road traffic. Or, for example, the London TMA is actually quite congested airspace at the moment. And then you go to try and stick in another 100 of these electric helicopters. They have to be IFR. We're starting to run out of space.
We're starting to run out of glossary.
No, IFR, I said that over any instrument flight rules. They're using instruments rather than looking out. Remember, there isn't the pilot on board, so you can't put anybody out there to look out to make sure they're separated from everything else. So it's going to be really interesting to see how these are going to be integrated into the airspace, how they can get deconflicted against all what we know as commercial aviation today, in and out from the Londons, the Gatwicks, the London cities and stuff like that. So yeah, there's a lot of work to be done, but I think we will need a lot of automation to ensure this happens safely. And of course, this is where we're moving. We introduce that technology to enable that to happen.
And that tracking point is really key as well, because we get asked this a lot, but there is at the moment so much reliance, I think, from regulators globally on trying to make things cooperative, so trying to make sure it's got some kind of broadcast signal. But from a risk management perspective, no one cares about people that are following the rules, right? The risk is about the people whose equipment is maybe malfunctioning, or they've just not switched it on, or they don't want to carry any equipment. That's, from a risk perspective, the bit that actually needs to be dealt with, and that's why, coming back to Skyway, that's one of the reasons that technology is so powerful. Because if you have a zone, like I forget what the CAA calls them, is it transponder mandatory zones?
Yeah, TMZ.
The problem with the TMZ is you can't tell if someone is in it if they don't have a transponder, if you're reliant on that as a method of detection, which is what Skyway can do. Right? The Skyway can see you, sense you, and then can work out if you're conspicuous or not electronically. So these types of technologies, solving these problems, are key to then being able to port that over a city like London, which, as you say, is hugely congested.
Yeah, and this is why NATS spent vast amounts of money a number of years ago, and I don't know exactly how many years, might be 10 or 15 years ago. They introduced a tool called CATE, so Controlled Airspace Infringement Tool, because they realised there's a big risk about other aircraft inadvertently accessing controlled airspace. It may be done accidentally, they may have generally just got lost, but it's a massive safety risk to commercial aviation. So if you mirror that across the TMZs, how do you prevent somebody who's not electronically conspicuous to enter? How do you prevent them from entering a TMZ? And if they do enter it, how are you going to know that they're in there?
How does NATS know? What was NATS's detection mechanism? Was it radar or something?
They initially used, they were only using secondary radar to detect when something had inadvertently penetrated controlled airspace. Thereafter, they could use primary radar, which obviously just primary radar is quite clever because they're not necessarily 3D radar. So you've got to use other calculations to actually identify, to see whether whether a general aviation aircraft had inadvertently penetrated controlled airspace. Quite clever stuff. As you know, I'm not technology minded, but NATS realised the risk, and therefore there is a risk, even with TMZs, that people accidentally enter that airspace. You don't know about it, and therefore it's a safety risk.
I'm assuming primary radar is incredibly expensive.
Hugely expensive, because it's line of sight, remember, and the coverage of the Earth. You're going to have in order to cover that lower 500 foot, you're potentially going to need a radar, every 5 miles? Something like that? Well, it's just not viable.
Plus, traditional ATM radar isn't designed to pick up tiny little aircraft, though, is it?
It's not at all.
I think that's one of the reasons why Skyway uses multiple different sensors. It can connect to radars, it can use those, but it doesn't rely on any one. And I think that's the key, right? Because there isn't, even from an airborne situation, people often say to us, why can't drones just all talk to themselves and all collaborate? And it seems like a logical idea, but the reality is there are so many reasons why that isn't possible now. And one of those reasons is there isn't a magic sensor that can detect everything in all situations, and that would be carryable by a drone, of various different sizes. So what Skyway does is it puts all that sensing equipment on the ground where things like power and weight aren't a concern, and then helps people to benefit from that by fusing it all together. So you create a situation where 1 and 1 is actually equal to 3 or 4 in some instances, rather than reliance on a single sensor. So I think that's why I asked the question around the ATM side. How did NATS plan to solve that? Well, the reality is they're not trying to solve for small aircraft at extremely low altitude. They're looking at higher altitudes, which is where you'll find a lot of that control airspace.
Well, that's where the money is, isn't it? That's where they get money from commercial aviation. They have route charges for the big airlines, the British Airways of this world, transiting through the airspace. They don't think about everything else is potentially clutter. So you have, just quickly, they have speed gates on radars. So if something is moving, deemed to be moving, for example, less than 60 miles an hour, it gets automatically filtered out. Because you want to have a clear picture for the ATCOs to look at. The air traffic controller wants to see a clear picture. Doesn't want a load of mess on there, a load of background noise, as it were, being picked up by clouds, by birds. So you try and clear that picture out as much as possible. And one of the methods is by putting a speed gate on. And if that's set to 60 miles an hour, well, you're not going to see anything which operates below that speed, so all of a sudden things start to disappear. And that could potentially take out a lot of drones anyway. So you've got to think about those things.
Gents, it's been an absolute pleasure, as always. And if you've enjoyed this, then please share on the various social channels. You'll find us on Twitter, LinkedIn,
Facebook, Instagram,
and
this man's head of PR.
Yeah, not social media.
So, well, thank you. I want to thank our producer, Cos. And we'll see you next time on air. Thank you.